Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture we will discuss the conditions of equilibrium for a floating body. Okay. In our previous lectures we already have seen different terms and conditions about what is buoyancy and what is the force of buoyancy and what is center of buoyancy. So all these things we have discussed previously. And along with that also we have discussed the terms metacenter and the metacentric height. Then also we have discussed regarding the center of gravity along with this. So now these are the terms are going to use for us in this lecture. Okay. So what is the condition of equilibrium for a floating body? So when the body is in floating condition, then what are these conditions of equilibrium for that? Okay, whether the body is going to be stable. Okay, so first point, let me write whether the body is going to stable or whether the body is going to unstable or whether the body is going to neutral equilibrium. So these are the three conditions of equilibrium: stable equilibrium, unstable equilibrium and neutral equilibrium. So when the body is going to be shows the equilibrium condition like this. So let try to understand the concept of this. Okay, so first what I will do, let me draw a diagram of body. Yeah, and this body is in the floating condition in a liquid such as water, and this body is going to rotate. Okay, let first draw this water line. Okay, now this is the water which is present and the body is floating in this water condition. Okay, now when the body is placed like this, obviously we have a axis line of this body. So draw the axis line in this, and we know that the center of gravity of this body will be at the center point of this object. So this is known as our G point, center of gravity point, okay, which exists on the axis line of this body. And similarly, the center of buoyancy also will be exist on the same axis line, but below to this gravity, based on that how much portion of this object is inside the water level. So that is B point, okay, center of buoyancy point. So we know that previously already we have discussed. That means in this center of gravity, the total weight of this body will be exist. So that weight will be vertically downward. Okay, and similarly at this B point, we can say that is the center of buoyancy. Our force of buoyancy or buoyancy force is going to act, that is acting upward. Okay, these things already we have discussed previously also. Now when the body is going to rotate, this body is in now this condition. Let rotate this body with some angular displacement with clockwise direction. So it will be like this, suppose, and the same water line is there. Yeah, just draw like this. Now when it is rotated, then obviously you can see this is the axis line. You can give some rotation symbol and let again mark the point of B here. This is the G point and the B point is here. Okay, now this is G and this is B. Now G point will be as usual at this initial point, but the B point, the center of buoyancy point, is not going to in the original position. It is going to change its position from here to with some distance to the right side, because the body rotated in the clockwise direction, in this direction, right side direction. That's why the center of buoyancy also going to change its location from B point to B1 point. So the force of buoyancy also going to act on this point, because if you see initially the body in this condition is there. Now after rotation, the position of this right side or the area of this right side, if you see, it is increased than the previous one. That's why the center of buoyancy also changed from B to B1 point. So this is B1 point. And the force of buoyancy also going to act at this point. Okay. Now, if you draw this force of buoyancy, the line of action of this force of buoyancy vertically upward, then this line is going to meet at a point in the axis line of this. So this line, this point is nothing but M point, and that is known as metacenter. So we have already discussed buoyancy and the force of buoyancy, center of buoyancy. Now metacenter M. Okay. Now force of buoyancy is going to act here, but our G point, as usual, the weight of this body is going to act downward direction. That is the W, which is going to act downward direction. We know that one. Then only the body will be in the equilibrium condition. What is this value of W will be equal to the value of FB. Okay. Now this is the condition. Now for when we can say this body is going to be stable. Now when our M point, the metacentric point, when the metacentric point is above G point, then it is called stable equilibrium. Okay, that means again it can be back to its original position even after slight rotation also, even after changes of this direction, okay, or some angular displacement happened also, we can again back to the original position of that, and this angle is nothing but theta. So when the condition will be stable, now when M is above G point, and the value of Gm will be not equal to 0. It will be always a positive value. We can get some positive value of this metacentric height. Okay. Now this is about the stable one. Now when it can called as an unstable one? Now, unstable one will be similarly. We can say again one body, let's consider, which is floating on this, and this is the water line, and again let draw like this. So this is actually in this object, like upper part of this, like somehow thicker, and when it's going to rotate, let it rotate again in the clockwise direction. Now after rotation also, and this one also you can feel it water. So same like previously what I have mentioned, similarly I can mark some points GB, like gravity point and buoyancy point in this. So let's draw the axis line on this, and this is, as we know, this is our gravity point and this is our center of buoyancy point. Correct. Now if you slightly rotate this one, then again it is going to change its axis line, and this one also, let's draw this a little bit. Yeah, and now see, if you see the G point, it will be as usual in depth point only, but due to these changes or due to this rotation or due to this angular displacement of this in the clockwise direction, when the body is rotated in this way, and again the B point is not going to be at its original point, it is going to change its position to some distance, okay, which I'm suppose let some distance of B1 point, let some distance of B1 point. Okay, now G point, let it keep little bit up. Okay, G point, let it keep some little bit height. Yeah, so let it here, because due to this heavy one in the top, the most of the weight will be at this upper side. Okay, let it draw there. So B1 point will be here. Okay, now for this condition, as I told you previously, again just the line of action is going to, that means the force of buoyancy is going to act at this point. So this is force of buoyancy. Now if I extend this line of action, you can get a line like this, though a little bit inclined, but suppose let the line of action is meeting the axis line at this point, then obviously what will happen? This will be our metacenter, and this is our center of gravity, here. Now we know that the weight of this object, weight of the body is going to act on this. So that means the weight of the body is here. Okay. Now for this condition, if you see, when the metacenter is below the center of gravity point. Now see, the M point is below the G point, that means the metacenter is below the G point, gravity point. Then at that condition we can say the body is at unstable condition. It is not in the stable condition. We cannot back the body to the original position again if you want also. And here the GM value will be always negative. It is always negative. There will be no positive one. You see, negative will be get this value. So this is about the unstable one, when we can say the body is unstable. Now if the M is below than the G, then it is called unstable one. Okay. So now if you see the couple which is created in the clockwise direction due to the buoyancy force and the W, if you see this buoyancy force and the W here, okay. Now see, this buoyancy force is acting upward, okay, and the W, the weight of this object, is moving downward, correct. So there is a couple formation is here happen, okay. And this is over tuning, you see. Now previously if you see, that is different. Previously it was, this is our G point, W point, and this is our force of buoyancy here, okay. So it is, one direction is there. Now for this, it is, though it is moving in the clockwise direction, but this movement of this is overturning, okay, and overturning the floating. When it is floating in this, overturning means it is going to be sinked in the water. That's why again this body is not going to be back its original position if you remove this angular displacement. That's why it is called unstable one. And when the body is going to stable, now when the M point and G point acting both at the body, so you can write when M is at G point, then we can say the body floating in the neutral equilibrium. For this, what we can how we can denote this one, you can just, let me take a body here. Now suppose at such condition, at some condition, this is initial condition of this, okay, this is the G point and this is the B point. Even after turning also, if some condition will be there where the M point and G point both are going to meet at the same level. Suppose after turning this, let's draw something like this. Now again this is going to rotate. Now this is the B point and this is the G point. And even if you see, the B point is going to change its position due to the rotation of this, okay, slight rotation is there, and this is the B1 point, and the force of buoyancy which is going to act here, that is going to straight like this. Then you can see this is the meeting point. So the meeting point is nothing but, we know, that metacenter. So in such condition, okay, when the metacenter is equal existing or is meeting the G point, that is called a neutral equilibrium. Okay, so these are the types of or conditions of equilibrium for a floating body. So I hope you understand what is stable equilibrium, what is unstable equilibrium, and what is neutral equilibrium. If you are having any doubt, you can give a comment on the comment box. Thank you all.